Okay, problem from section 9.3, question number 5 I'm doing here, but for any questions you can use the same idea for this section. Okay, listed in the data you can see the data of height of mother and daughter, and you know it they appear as a pair. Okay, the data pairs are from a journal kept by the Francis Galton. So this is the data we have given. Now we need to find out and what else we have given. Use the listed pair sample data and assume that the samples are simple random samples and that the difference have a distribution that is approximately normal. Use a 0.01 significance level to test the claim that there is no difference in height between mother and their first daughter. So here mu d, it means the average of the difference between the height, and null hypothesis means there is no difference, so the mean has to be 0. That's the null hypothesis. And alternate hypothesis is it's not equal to 0. Okay, not equal to 0. So in this example, mu d is the mean value of the difference d for the population of all pairs of data, where each individual difference d is defined as the daughter's height minus the mother's height. What are the null and alternative hypotheses? So the null hypothesis is there is no difference, and then alternate hypothesis is yes, there is a difference. So that means mean should not be equal to 0. Okay, so now to find the value of t, you can use this data, and you can use the calculator to find the value of t. So this is TI-83 I'm using, but you can also use TI-84. First of all, go to stat and go to number 1, which gives you the list of your data. You can put here I'm going to put this list as a difference between this height, so like 64, 66. So the difference between daughter and mother. And remember, this mu d means as you can see here is the mean value of the difference d for the population of all pure data, where each difference d is defined as the daughter side. So you subtract mother side from the daughter side. So 66 minus 64 is 2. So that's the first data. 63 minus 63 is 0. 67 minus 64 is 3. And 62 minus 63 is minus 1. And 68 minus 64 is 4. Where is that? Yes. 63.5 minus 63.5 is 0. And 66 minus 63 is 3. 66 minus 62 is 4. 62 minus 65 is negative 3. And what is that? 68.5 minus 68, so that means 0.5. So these are the 10 data. 1, 2, 3, what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is our data. L1 is our list. Okay, now to find the value of t, go to stat one more time, go to test, and there is a t-test number 2. Hit there, number 2. We're using the data, and our data is stored in L1 list, and now frequency is 1 always, and the mu d, which is mu here, is not equal to this value. So this is not equal to this value. Okay, so we are choosing the not equal here, because if you need to find like this is greater than 0, then you choose the greater than sign. Less than 0, then you choose the second one, but here we are interested to find not equal to 0, so the first one is the option. And now if you go down and calculate, it's going to give you the value of t. T value is 1.7, rounded to the 2 decimal place. So that is your t value, this is your p value, this is the average, which is the d, and this is the standard deviation for the difference, and this is the number of data. Okay, so t value is 1.70. Okay, and now the p-value, we already found the p-value here, which is 0.1232, and rounded to the 3 decimal place, so 0.123. And now since the p-value is as you can see that we would like to find out the significance level is 0.01, and p-value is greater than that. So since p-value is greater than the significance level, so we are not do not reject the null hypothesis. There is sufficient evidence to warrant rejection of the claim that there is no difference in height. No, there is not sufficient evidence to warrant rejection of the claim that there is no difference in height. So since the p-value is greater than the significance level, we need to reject the null hypothesis because this is greater than, and let's check it. Oh, what did I wrong? So the only, at least one of the, okay. Since the p-value is greater than the significance level, this is right because this is greater than 0.01, and comma, reject the null hypothesis. Do not reject the null hypothesis. There is not sufficient evidence to warrant rejection of the claim that there is no difference in height between mothers and their first daughter. Yes, so that's the right choice. Do not reject. Okay. Yes. So in this way, you can solve this type of problem.